Joe, we're going to be talking about black holes. So Adam, what are black holes?
Well, so that's a very good question. I'm glad you've asked it. A black hole is a region of space and time from which gravity pulls so much that even light cannot get out. This means that it is invisible, and this is why it's called a black hole.
The reason the gravity is so strong in the black hole is because the matter is pulled into a tiny space. This occurs when a star is dying.
Black holes can be big or small. Scientists think that the smallest black holes are as small as one atom. These black holes are very thin, but have a mass of a large mountain.
Another kind of black hole is called stellar. Its mass can be up to 20 times more than the mass of the Sun. There could be many more stellar black holes contained within the Milky Way.
The largest black holes are called supermassive black holes. These holes have masses that are more than 1 million suns together. Scientists have found that every galaxy contains a supermassive black hole in its centre.
The supermassive black hole in the centre of the Milky Way galaxy is called Sagittarius A. It has a mass equal to about 4 million suns and would fit inside a very big ball that could fit in over 1 million Earths.
Stellar black holes are made when the centre of a very big star falls upon itself or collapses. When this happens, it causes a supernova. A supernova is an exploding star that blasts part of the star into space.
So Adam, should we be worried about a black hole threatening me?
Should we be worried about a black hole? Well, black holes don't go around eating stars, moons and planets. Earth will not fall into a black hole because no black hole is close enough to Earth to do that. Even if a black hole swapped places with the Sun and had the same masses as the Sun, Earth would still not fall into it. The black hole would have the same gravitational pull as the Sun. Earth and other planets would orbit the black hole as they orbit the Sun. The Sun would never turn into a black hole as it is not a big enough star to make a black hole. So no, Sam, you're safe as houses. Still me. Hold on, Adam. Hold on, Sam. If we can't see them, how do we even know they exist?
Well Adam, although it is true that we can't directly see these black holes, it is possible to observe these objects by their effect on the surroundings. Usually scientists look for the gravitational effects of black holes on companion stars or bursts of energy coming from superheated mass as it falls into the gravitational well.
This is an image taken in 1977 from the NASA Hubble Space Telescope. Using its onboard spectrograph Hubble, it was able to image the velocity of gases around the galaxy's core.
As you can see in the image, just here, the coloured line is clearly warped in the centre. This gave evidence for the theory of black holes, as in the absence of a strong gravitational field, the coloured line down the centre would be straight.
Expressed numerically, the gas within the 26 light-year radius around the centre of the galaxy was travelling at speeds in excess of 88,000 miles per hour. To induce such speeds, a massive body of at least 300 million times the mass of our Sun would have to be present.
Before we end this presentation, are there any questions from the audience? Yes, you sat there.
Hi Sam and Adam, I'm Joe. Absolutely fantastic presentation, by the way. I've learnt so much about black holes. I've just got two small questions. Firstly, is it possible for two black holes to collide or join together?
Well, that's a very good question, Joe, and you're very brave for asking that. Well, scientists believe that the interaction of two black holes could have one or two outcomes. The first is that they merge together to form one, much more massive black hole. The second is that due to the spin, the two black holes could interact and recoil from each other, sending one hurling away. Has that answered your question, Joe?
Yeah, thanks for that. And one more last question. If a black hole is a dead star, how does it die?
Well Joe, over time the black hole would eventually lose so much mass that it would become small and unstable. This is the dramatic end. The black hole would then lose the rest of its mass in a short amount of time as abrupt explosions. We can detect these explosions as gamma ray bursts.
Thanks Sam, that's completely answered my question.
Well, that's the end of our presentation today. I'd like to say thank you to the camera team for making this possible. I'd also like to say thank you to the Physics Department at Arnold Hill Academy. Very good presentation. And that's our time, is it, Sam?
Thank you everyone, yeah, that's it. Thanks everyone.